right, and let me just make sure that sharing works. Let's see if I can actually share my screen. Okay, that's looking okay for me.
Looks good.
All right, excellent. And let me bring up the chat sitting on the side. I will attempt to monitor the chat over here, but feel free just to come off mute and just be like, yo, if something goes weird or confusing. All right, so let's get into it. Catching exceptions exceptionally. Um, so this is what I'm covering today. First, what are exceptions? Just generally, what do they even do? Um, we're going to talk about the standard Salesforce exceptions. We're going to talk about custom ones that you can write yourself. Getting into a little bit on how to unit test for exception handling. And then the end with the worst thing, the uncatchable exceptions, the ones that basically just cause your program to crash. Um, I think everyone in the audience is probably applicable for this. Everyone here is studying PD1, Dev Bootcamp, so you're all the correct people in the room. I gave this presentation at Midwest Dreaming 2 years ago in 2024, and some admins were in the room, so I wanted to set the stage. Just as for me, I do have 20 certifications. I've been on the platform since 2015. I've been in IT since 2001. It's not a contest, Warren, but that's okay. Anyways, yeah, and if you want, you can follow me on Blue Sky. Is probably the best place to follow me at this moment for social media stuff, or LinkedIn, but Blue Sky is more fun. All right, let's get into it. What are exceptions? Let me make this a little bigger, just for fun. We'll make this even bigger. All right. So when I was an undergrad student at Syracuse University, my professor explained exceptions as an exception is an exceptional event. And I took out student loans. I agree. Yeah, I took out a student loan to learn that lesson. Now, to be fair to Professor Older, she did explain a lot more than that. And she's a very good professor. But I think this is a better analogy to what exceptions are. Basically, things are on fire. So when an exception happens, your program is a little bit on fire. It's not a lot on fire yet. It's just a little bit on fire. And you kind of have to have a choice. You either deal with the fire and put it out, or everything burns down and your program crashes and you're gone. It's one or the other, really. Exceptions are a tool we have as programmers. It's just one of the things that we can use. We don't have to use exceptions ever. We can write code around and never use exceptions. Exceptions used to never exist. If you go to code from like the 70s or 80s, they didn't have exceptions really. They just had full out crashes. They can be useful, they can be misused, or they can be used really, really conveniently. So let's get into the nature of exceptions. Exceptions are said to be thrown. That's the terminology, is that you throw an exception, that you have an exception here, and you're going to throw it across the room like that. Yeah. And if an exception's thrown, what ends up happening is we say that those exceptions that are thrown, the programs catch them like that. They catch the exception. If you catch the exception, that's good. That means you're dealing with it. If you don't catch the exception and it falls on the floor, that's bad. And that's when you get your programs to crash out. That's when you see those error messages that say uncaught exception. That's what it means. It means, hey, something went wrong and you didn't fix it, or you didn't deal with this scenario. So now we're just going to crash out and everything dies. And this is the nature of what exception handling looks like in code. Try, catch, and a finally block. That's it. This is exceptions. You try to execute some code. This is the code you're trying to execute. You're literally saying, please try to run this. And if something goes wrong, that's what the catch does. The catch says, ooh, something went wrong. And now you have code inside this whole block to deal with it and deal with whatever went wrong. The finally is it runs no matter what. So finally says, okay, you tried to do something, you caught this thing, now run this code. Or, hey, if nothing bad happens, the try code runs, the finally code runs. Finally is optional. You don't actually need to use it. Sometimes it makes sense, sometimes it doesn't make sense, sometimes it doesn't matter. If you have a try, you have to do a catch because there's no point without the catching. We're going to go and actually look at the code in a minute or two. All right, so let's start looking at some of this stuff. Let's start looking at exceptions. I'm going to pull up some code here. No, don't want that. Don't want that. I want you to be smaller so everyone could see this. I'm going to zoom in a little bit more. And all these here are my little cheat sheets. This is how I'm going to be running this class and this function or method. I think we call them methods. Class and method. I'm running it through anonymous Apex. This and then looking at the debug log. That's what this whole command does. It basically says run this code, run ce basic dot this method, and then it grabs the last log file so we could actually look at the debugs. This is a little more convenient than going into VS Code. Going into the dev console. But functionally, it's going to be the same. This is going to look at the log. So I'm going to run this code here.
And sorry to interrupt. Like this is very interesting because I have not run my code this way to get the tails of the logs. So I think that's really cool. I think that's really cool.
It's a fun little trick I learned. It's a little tricky to actually really get these logs. Like if you're doing it through anonymous Apex, this will work. I don't think it'll work as well if you're doing this like historical logs, like user logs and stuff like that. But I haven't played with it too much. And then I'm filtering out this last grep statement. I'm filtering out everything but the debug statements.
Very cool. And
So
we get this all the time. Sorry, this is the last thing. Like, if you're a
sure.
Windows user and trying to do this, it will most likely not work. Some of these commands don't exist in Windows. So you would have to switch the commands out because I get that question all the time when I do Mac commands.
Yep. It's very unfortunate. If you're doing this after this thing, take this line here, copy it, paste it into the dev console as anonymous Apex, and then just go to that tab that says logs, open the debug logs, hit debug, and you'll be able to see all of this. So what does this function do? It says point A, it prints out a debug statement. It tries to divide by 0, and then point B. And what we're seeing here in the logs, the errors pop up first. You see point A? So the system executes line 8. It executes that debug. Then it crashes out on line 9 because you can't divide by 0. And then line 10 doesn't even execute. Because if it did, we'd see the word point B here. So it's definitely crashing right here. And so it just goes and it dies. Here's how we catch those. Let's walk through the code. We go through point A. Then we try to do this try statement. If this line works, if line 21 works, we should see point B. Here's the catch block. If an exception is thrown, we should see point C. Oh, I'm gonna give you. I'm gonna put a link to all this code, by the way, Punchy. So you'll be able to have all this stuff and play with it later. I'll share the file, and the presentation deck as well. And then lastly, if all of this works and none of this crashes out, we should see point D. I copy and paste the right one. Oh, look at that. That's weird. I only put that point A. Did I copy right? Oh, that's interesting. I wonder why that's failing out. Oh, maybe let me make sure the source code is actually deployed. All right, and deploy. There we go. And make sure I got my codes actually up in the org. Oh, now why is that going like that? Let's see. Let's look in the org itself. And I'm wondering if that could be a limitation of the way I'm grabbing logs. So I'm going to try running this code directly here in anonymous Apex, and let's just see if it does it differently. Oh, it did. Okay. You see, you remember how I said like sometimes this goes funky? It's going funky on me right here. All right. What do we see? A, C, and D. So what happened here? Point A executes. It crashes on line 21. So all the stuff in the try below 21 doesn't execute. It dies out here and it says, I'm done with this thing. I'm done. And then it goes to the catch block. And then the catch block catches it, puts out point C. Then all that work is all that's fine. So it goes very to the end here. It says, okay, I'm going to put out point D and I'm done with my life. Here's an example with a finally. Let's put the finally in there. Does point A, crashes on this line. Does point C, the finally executes, and then point E runs. If we didn't have this error, right? So I'm gonna open, since I have this open here. This error is on what, line 39? I'm gonna comment that out so that it doesn't error. And what we should see is A, B, D, E. A, B, D, and E. Let's get a little more interesting. This one, what are we doing in this function? Put up point A. Here's our try statement. We're going to divide by 0 and then try to insert an account. We're going to catch an exception. And then we have something after it. So intuitively, this should fail on line 61. Let's find out if it does. Point A, point C says divide by 0, and point D. And if we look back at the code, point A fails out here. We get to point C. I'm now outputting the message. You see here, e.get message. This is telling me exactly why this exception was thrown. It's the exception's error message. And the error message is divide by 0. Basically, don't do that. This is a way to actually find out why an exception occurred. And then you could use this information in your code. So your code, you can actually say, all right, what's the exception? How do I handle it? Because different things could happen. Let's say I'm going to take this code here. And let's say for the moment that we don't have that divide by 0. What's going to happen if I run this code? What do you think is going to happen? Yell out an answer. Is this going to work?
Going to be missing a name, I believe, missing some fields.
Haha, missing fields. Let's find out. I'm going to run it. Point A, point C, exception thrown. You see here? There's the exception, missing field, missing name field. So the same exact code path happened. The same lines basically were executed more or less. Except when this inserted, now instead of throwing a divide by zero message, now we get an insert failed error. So this is showing that you get different exceptions and you could handle different exceptions differently. You know, an exception by itself is one thing, but what type of exception is a better question. This one here, this code will illustrate that as well. Notice I have two catch blocks, one for a math exception and one for any other type of exception. This is yet another thing you can do. Wow, look at this. This dev console is getting funky. Do you see how it gives a math error? Because it catches that that's a math exception. And this particular code right here, right now, we had that divide by zero. If I take that out and I rerun the code, now you see it goes account error. I'm taking an assumption here that this was an account error because I know this code, right? But this is showing that you can catch different types of exceptions and handle the different types of exceptions differently, depending on what's actually thrown. Here's an example with finally. I'm not going to do this one. You could do this one on your own if you want. This should execute point D over here. Here's a link to all the standard, or at least most of the standard exceptions that Salesforce throws. There are occasions I've seen where you could throw these exceptions, like you could throw a divide by zero or a count insert exception, one of these standard ones. You can't always do the standard ones. Sometimes you can, sometimes you can't. I usually don't like to do them. I usually like to say standard exceptions should only be Salesforce's problem to throw. If I'm going to throw an exception myself, I'm going to throw a custom one. Only exception there is the or, what is it called? It's the or one, and I can't remember the name of it. Or handle exception. The only reason I would throw this standard one is because then it tells your OR components, and I think your Lightning Web components, hey, something bad happened on the Apex side, you go deal with this on the front end. So that's my only exception. All these other ones, I usually just let Salesforce deal with it. And there's a lot, as you can see, there's a lot of different things, that can go wrong. Null pointer exception, that happens a lot. That one sucks. You'll see it quite often. Don't worry about it. You know, just deal with it. These are some of the most common ones. DML exception, that happens a lot. That's where you have your problems with your inserts, your updates, validation rules, missing fields. They're going to usually throw a DML exception. If you're dealing with integrations, you might see JSON exception a lot. That's when your JSON file, you're trying to parse your JSON into like an object, and they don't match up, or they're wrong, or someone made a mistake, and you get a whole bunch of error. List exceptions, this is if you're like, you have a list of let's say you have a list of strings. There's 5 things in the list, and you try to access the 6th thing by saying, you know, your list variable bracket 6, and it doesn't exist. You're gonna get one of those. You got math exceptions, null pointer. These are kind of annoying. Like, here's an example of one. If you have a null string value and you try to convert that null string to lowercase, this lowercase function doesn't like working on those. It says, what are you doing? And instead of just returning null, it throws an exception. Very annoying, but you can handle it. Query exceptions. This happens when you do select statements. I think most of these should be catchable. Some of them might not be. We'll get into that. And the OR one to return errors to Lightning components. So why do we use these exceptions? Unlike a status code that your function might return, exceptions have to be handled. The code requires you to deal with these things. You have to either gracefully handle it and correct the problem, or it's going to blow stuff away. If you catch an exception, you might have to do your own rollbacks. Because like normally, if an unhandled exception happens and you inserted a record, the database rolls back and says, oh, there was a problem. We're going to do a full rollback. If you catch that insert problem, if you catch that exception, it's not going to be told, hey, there was a problem, because called exceptions are considered not a problem according to Salesforce. So you may have to roll back certain pieces of code or certain whatever's you're doing if you catch the things. This is very code dependent on what you're doing. The biggest purpose of this functions of exceptions is it tells whatever was calling this piece of code, right? So you're calling a method and you're saying, do something for me. It passes the message back saying something went wrong. And this passing the message back is recursive up the stack. It tells the thing that called the thing that something went wrong. Normally, you can only pass a message back to the function that calls. You go down one level, you can only pass a message back one. Exceptions keep bubbling all the way up to the top. Here's an example of why that could be bad. Imagine a piece of code where you're checking if a user is authorized for access. And you say, okay, if they're not authorized, return a string that says no access, otherwise return an okay. What if the function that called this block of code doesn't check this value and doesn't check if the user is authorized? Something bad could happen. If you throw an exception, the thing that called that code now has to deal with it, and everything above it that called that code has to deal with it. I'm going to show an example of recursion, of this recursive nature. I have here a block of code where we try to call a function, we catch the exception, and if we catch the exception, we output the error message. Just calls this, and you see, you could have little helper methods that you could pass these exceptions to. They're just objects, just like anything else. They're variables, just like anything else in the system. You could pass them to different functions. And this outputs this. What does B do? B returns a value in C. C returns a value in D. D calls E, calls F. This is cascading down. It's a function calling a function, calling a function, calling a function, until at the very bottom here where we have a divide by zero error. And so what ends up happening on this, and I'm gonna execute this in the dev console here. We're gonna open that up. Beginning it, error occurred somewhere deep, divide by zero. These lines are being outputted. The line 45. You notice I can get the line number, the exceptions on, very handy for debugging. So the error occurs all the way down here on line 45. And what happens is this throws the exception. Function I throws the exception, which goes into H. And H says, I'm not handling this, someone else deal with it. And it throws it back up to G, and it goes all the way up until A has the catch section. And A catches that exception. It gets called all the way up here and handles that. If I didn't have this in a try catch, this entire thing would just blow up. You get unhandled exception errors. But it goes up and down. That error goes all the way up the chain to the very top, and there's nothing above A. This was the function I called directly. So if this wasn't here, A is the last thing at the top, and it says, now I'm done. And so that's where the unhandled exceptions occur, is that A is the highest point of entry, and it doesn't handle it. So it says, all right, I'm dead, and it errors out. Let's look at custom exceptions. These are actually surprisingly easy. I'm going to show you what a custom exception looks like. This code right here, that's all you need to create a custom exception. Just that. You don't have to put anything else. You could put this, I believe you can put these inside a class, so they could be an inner class. I don't know if you guys covered that topic yet. Inner classes. If you have, I think you can put them inside. You don't have to have them separate, but I just did. And you could put overrides and other stuff in here. You don't need to. You know, there's advanced stuff in here. I'm not even worried about it. And so what can we do with that? So I have, let's say I have a book reservation system that I wrote some code for that. I wrote a book reservation code. And I'm checking if a book's available. And if a book is not available, I want to throw an exception. I don't want to return a no value. I don't want to return a Boolean. I want to throw an exception. So here's the simple code. I'm going to call reserve book, and I'm going to get a book name. Boolean, is it available? If it's not available, throw this custom exception. Book is not available. And I have, you notice I can put my own string in there. This is very simplistic code. This code is always going to return a false value. Pretend for the moment we actually did something in here to actually check, maybe query a database, do a web call out. This is purposely silly. So I'm going to copy that. I'm going to paste it in here, and we're going to see what happens. And we got the exception. Book is not available. The Food Force for Good cookbook. You notice the exception is my custom exception. So when you write your own programs, you could build your own exceptions and figure out your own exception handling and how you want to handle that. Maybe you'll have exceptions for your org. Maybe you'll have exceptions thrown on like a module basis to say like this particular bunch of code does one thing. I want to have an exception just for this. I want this thing to have its own set of exceptions. I want this to have its own exceptions. Maybe I want my entire org to have one master set of exceptions I throw. A lot of that is very situational, depending on the organization you're in and whatever the people prior to you did and decided. You know, because when we go into a new org, when we go get hired somewhere, we have to integrate with the way things used to work. And sometimes people don't work the same. And sometimes people do really silly things. And we have to just deal with that as developers. I want to get into some things not to do. First, I have seen this in production code. Do not do this. Can you guess why you should not do this? I'll give you a hint. Because no one will see it running actually. Yeah, pretty much. Let's say this insert fails, right? We call this code, this insert failed. We're catching the exception. We're throwing something to a debug message that no one's ever going to read because no one's going to see the debug logs because those aren't on in production usually. And we don't actually handle anything. We just say, hey, an error occurred. No error occurred, and we just go on with our life. This is an example of the this is fine dog where everything's on fire and you're just sitting there being like, it's nice, whatever, you know. I've seen this in prod. It hides errors, and usually the people who do this are actually not very good developers who don't know what they're doing, and they're using it to hide the mistakes. So just something to watch for. If you see that, you're probably going to have a rough time in working with that code. Just a preemptive warning. Here's another thing to avoid doing. Here, I have a try. I have a catch that doesn't do anything. And do you see this line of code right here? I'm setting on a case the account ID equal to the value of this inserted field, this inserted record. This line of code that I've highlighted assumes that this succeeded. And if this failed, the exception's caught, but the code below it is going to error out because it's going to say that ID doesn't exist. What are you doing? So if you catch stuff, one of the important things to know is that whatever occurs after the catch has to deal with the scenario, has to deal with the possibility that this could have worked or it could have failed. Something to think about as you architect your code is if an exception occurs and I catch that exception, are there ramifications for the code that occurs below it? Unit testing, one of my favorite categories. You could unit test exception handling. You get a unit test that exceptions get thrown, and you do that by trying and catching inside the unit test. And when you do that, you want to make sure that the catch block is actually executed and you get the exception you're expecting. Let's see an example. This is a bad unit test for doing it. All the framework is here. We try to insert this unit test. We're assuming that this is going to fail. We have our catch, and we assert that I assert that I got this validation rule didn't fire error message. The problem with this unit test is, what if this insert record actually passed? What if this worked without throwing an exception? This will never execute. This whole block will never execute, and this unit test will pass. It will pass when we weren't expecting it to pass. We were expecting this to occur. So this is a little better, and this is what I usually do for this scenario. Is I have a value that says a Boolean that says, "Hey, error detected." It's false. We try to do the insert and the catch statement. If Warren got it right. Kayla and I are the only two that care about unit tests. That's not really true. There's many of us who care, but not enough. Yeah, or at least don't understand the benefits of the unit test. I think is more of a key, but that's getting off track. Anyways, this catch will set this variable to true, and my assertion is that error detected is true. So if this catch never executes, if this inserts correctly, this stays as false. And then asserts is true. Well, that's going to be false. So that's going to fail the unit test, as I would expect. But notice I said this is an all right unit test. This isn't the best. This is a better unit test, where instead of just saying did it occur or not, I'm actually getting the message. And I'm asserting that the error message was the correct exception. And the reason I do that, and the reason that's better, is what if this did not fail? What if this did not fail because I got a validation exception? What if this failed because I divided by 0? That's an exception as well. And this unit test, this all right one, just says if any exception happens, oh, okay, exception happens. This is what I expected. But I got the wrong exception. Something bad happened, but something bad happened that I was not expecting. It was a different bad thing. And that's why you want to check that whenever you check, hey, something bad occurred. It's the bad thing I wanted it to be bad occurred, not some other weird, random, bad thing. Lastly, there are a few uncatchable exceptions. These are usually occur because of governor limit issues. When these happen, Salesforce says, I don't care about your catch blocks. I don't care about your finally blocks. Your code is using too many resources. Your code dies right now. I'm going to show the example right here with this uncatchable. This is a piece of code Salesforce would like you not to run. This is going to take this string here, and it's going to take that string and add it to this string. How many times is that? About 1, 2, 3, 1, 2, 3, about 1 million times. So it's trying to loop, creating this big, huge string. And you'll notice I have point A here, I have point B, I catch the exception, and I have a finally block. Let's see what actually happens when I run this. I'm going to bring the code back up over here just so we can walk this. So it's taking its time. It's taking exception heap. You see that? That's a hard limit. This is a governor limitation. And let me open the debug log. It gets to point A. There's point A. Somewhere in here is where it dies. And it's uncatchable. So it doesn't execute this past the try. It doesn't execute the thing in the catch. It doesn't execute the thing in the finally. It just says your program is done. You're cut off. These suck. As developers, these suck because you can't catch them and handle them. And the only way really to deal with that is to refactor your code, change around the way you do your system, do more error checking. Check the size. If you get too many queries, you got to check if the queries are too big. There's a bunch of different techniques you could use, but unfortunately, try catch is not one of them for those. Salesforce puts those limits on us. Other programming languages out there might not have those limits, so crap like that might be catchable in like Java or Python. I don't know. But in the Salesforce ecosystem, you're host. And that's it for that. So now I'll open up for questions.
Yep, I actually have a question about uncatchable exceptions themselves. I'm working on an observability tool, POC, and I'm looking for ways of surfacing these uncatchable exceptions. And as you obviously pointed out, they are not able to be catched with the try blocks statements. So I was wondering, is there any way I can surface those to redirect them to my debug tool?
Inside of Apex and on platform, I'm not sure of a good way of doing that. There may be, if you talk to certain app exchange vendors who deal with some of this stuff about debugging, they might have found a way to kind of get around it or kind of figure it out. It's probably a lot of hacky things involving looking at like debug logs and all sorts of other weird stuff. So there may be a way. If there is natively, I don't know how to do it. If you have an outside system calling into Salesforce, so like certain integrations, they may be able to capture those and at least bubble those up somewhere or handle it. So like an outside system calling into Salesforce, maybe then they could handle some of those uncatchables. On platform, I'm not too sure. I know Richard you says about the limits class. The limits class is really good for finding out like if something went wrong and it is catchable. If it's catchable, you could use the limits class to say, what was the limit at this point in time? And, how much am I allowed and what did I use? The limits class is good for preemptively saying, oh, something's about to go wrong, or catching an exception and saying, oh, what went wrong? But the uncatchable exceptions aren't going to help you too much with the limits class. You may be able to use that in your code to, in debug logs, output your limit points. So you could say, okay, if I have, let's say I have a loop, I could query and debug log the limit at the start of each loop. And so if I have the scenario where like I have like a CPU timeout, I could see in the debug logs the amount it's going up and how far into that loop I used. It's not really a preemptive thing necessarily, but it could be handy for troubleshooting purposes and trying to figure out when did the problem occur and why. A lot of times when you get these weird exceptions, and especially like the government limit issues, trying to figure out how big or how close you were to that limit is an issue that a lot of people have. Are we like do we go over by one record or do we go over by like 10 million records? Big difference.
Okay, maybe try fetching the debug logs, maybe.
That might work. Yeah, you might want to look around there or around online to see. I said, I'm not aware of any way to do what you're looking to do. Now, that's not saying it's impossible. I'm just saying I don't have that knowledge. And if you could figure it out, that might make a pretty good community conference presentation or a local user group.
Sorry.
So I hope you figure it out and then share that info with everyone, because I would like to know. I am very curious.
Sorry for the technical question.
No.
Thank you for the presentation.
Thank you.
I feel like we encourage technical questions. I agree with Mike there on at least on preemptively. if you can somehow check the limit class, then you may be able to know if you're brushing up against the limit. But once they happen, you're out of luck. One,
Yeah, and sometimes there one, if you're near a limit, it may make sense to throw your own exception to try to
mhm.
kill whatever's happening before the user sees that something went wrong,
Yeah.
and then you could hopefully handle it.
But you imagine you need, however you're trying to, if you're trying to just integrate this into one org, then you just have a process set up for doing these checks. But if you're trying to like make a package or something like that, then you have to dictate what, like, making sure that whoever is creating code is following these things. So one thing that comes to mind is like the Nebula logger and that whole framework,
Mm.
right? So if you can then build some sort of framework that people follow, either for logging or something else, and it has baked into it, okay, we're going to check limits at, whenever a method is called or whenever you do this specific piece, and then that reports back out to whatever third party system you have or whatever system you have. Yeah, it's an interesting problem. It's an interesting problem for sure.
Yeah, I've used Nebula. It's a great tool. Okay, thanks, guys.
I've got a question.
Sure.
Being relatively new at this, everyone, thinking about catching things in an add feature context, like call out, and then needing to handle that with some other call out or some other feature. So my question comes back to transactions and the limit. Does all the air handling happen within the transaction, or is it a separate transaction? I'm just trying to understand the architecture behind everything here.
You could almost think of it for a moment as if it was like a branch in your code. So whenever that exception is thrown, if you have these try catches, you can almost think of whenever an exception occurs in your try, imagine little imaginary if statements on every line of code saying, hey, if something went wrong, go to the catch. If something went wrong, go to the catch, and then just go there immediately and never return. So the stuff that occurs in the try and the stuff that occurs in the catch and the stuff that occurs within the finalies are all in the same Apex transaction. If you have a catch and you throw an exception at that point that's unhandled, it's going to roll back your entire everything because it says, oh, this entire thing failed. It's going to roll back as if you didn't have anything there. So all of that does occur. If you, let's say, in a catch statement, call a queuable, and you enqueue a job or you call a future method, those are going to occur in separate transactions, just like any other code, right? Anywhere else in the system, you call a queuable, that's a separate transaction, that's setting over there. So that's still the same. But yeah, that catch block is still running in line, still with the same governor limit issues. So like you can't, if you query 50,000 records in your try, and then your catch tries to query another record, it's going to throw a too many rows exception. So it does share the limit, all the limits, everything's all shared. It's all still running in one block.
So you're limited. If you do an add feature for a call out and the error's there, and then you want to send an email to your system admins or somebody, and you want to do that in an add feature, that will fail because you can't do that together.
So you mean calling a future within a future?
Right.
Yeah,
I'm asking you, would that result in calling a future from a future? And I think it does.
I think it does. If you're using a future method, there are ways around that. Like you could use queues. So you could instead of calling a future from a future, you call a queue, or you fire off a platform event, or you do it synchronously in there, and you say, okay, well, I'm in the future anyways, in this, so instead of doing a future send email, I'm going to do it right now in line. The one good thing about exception handling in the context of futures, if something goes wrong when a user, and it's in the now, right? If something went wrong and the user hits the save button and something went wrong, they get to see the error message. It pops up to them. On all these future and asynchronous things, if something fails there, an exception happens in the future, the user doesn't see any of those. It's happening over there. So the user doesn't know, or the administrator or someone doesn't know that something in the future methods or your cubables, your asyncs, they don't see any of that stuff, which makes the exception handling even more important. Because in the present, people will see an error message and say, and email you saying, "Hey, Salesforce is broken. You guys suck." You know, it's happened 7 times today to me. But future stuff is hidden from the user. So like that's even more important. It's even more important in some ways to handle the exceptions in the future and to do a rollback or do whatever you might need to do, when something goes wrong.
Oh, thank you.
Sure.
Hey Mike, can you share the code and this PPT file?
Yeah, so here's a good question, Warren. What's the best way for me to share this info?
You can just send it to me and I will get it sent out to everybody. So you don't have to worry about it.
Oh, lovely.
Yeah. I make it easy.
Or should I just throw it on the
If
Slack?
you have it in like Slack is fine, put it in Zoom, wherever you put it, I'll make sure it gets sent out to everybody.
All right. Tell you what, I'm gonna put this upload. I'm gonna upload this right now to the announcements channel and under the post for this thing.
Perfect.
And where do you have any Slack channel for this Salesforce developer?
Yes. So if somehow you ended up in here when not in a Slack channel, I will give you the link to join the Salesforce Mentor Slack.
Okay. Yeah.
And that's you'll get a lot of the updates there if you're not in Cloud Code officially. But yeah, so I'll update both sections in there, and then there I just put it in the Zoom. That's a short link to jump into the specific pieces.
Thank you.
I've got a question, but I want to make sure everybody else, if you have any more questions either on the presentation, exception handling, any of that stuff, you can get through it. All right. I'll shoot with are you ready, Mike? I know you were doing some
Sure.
uploads. So
Yep.
my question is, one, great presentation. I'm definitely guilty of doing like kind of those ending pieces of the exception testing where it's like, all right, it's good, just send it through. So I saw, that better form that you mentioned, which was adding in the messages and doing the checks. How do you deal with dynamic messages that could potentially come through there, right? So maybe your error message has like a record ID or some other values that come through with it.
Yeah, so it depends. Sometimes I will just use a contains and just make sure the right exceptions are on. So if I'm just expecting a validation rule to fail, I might just say, all right, do I see the word validation rule? I might copy and paste and say like part of the validation rule message, or I might say whatever parts of the message that I know about. One of the downsides to being too tightly coupled is if the messaging changes, it might fail the unit test when you really don't want it to. Some ways to get around this is if in the code, maybe make make some or all of the error message a variable that could be accessed somewhere, like a global variable or a
right.
and then you could say, does the error message contain whatever class has my error messages dot whatever specific one, and look for this specific variable. So like if it's modified, you actually check, you don't have to update the unit test, it's just pulling it from somewhere else. A lot of people do that where like almost all the error messaging displayed to a user is none of it's in line, all of it's in like its own special classes or at the top of the code or somewhere. I find it a pain in the neck to work that way, but it makes so much sense architecturally. Like it makes a lot of sense development wise, and it's such a pain, and that's why like I'm guilty of not doing it too.
Yeah.
It's very handy for internationalization, but that's a different problem.
Right, different beast. Okay, that totally makes sense, right? And then, using either that specific phrasing or whatever it is to just
Mm-hmm.
check the values that you're looking for. I like that. That's really smart. And it's not like it's crazy hard to do. I think it's just like I'm more lazy or didn't really know some best practices and these sort of things that you're mentioning here. So that's really cool.
I mean, there's so much to know with software engineering that it's so easy to miss
Mm-hmm.
best practices all over the place because we're all, we're all busy and we're trying to deliver stuff and not take
Yeah.
20 years,
Yeah.
So Mike, I have a question for you.
Yeah.
So I'm new to the Salesforce uh, ecosystem.
Mhm.
Been trying to learn the coding and prepare for the PD1.
Mhm.
Do you have any resources that you recommend for people trying to become developers?
Yeah, Career Code, Cloud Code Academy has something called Cohort 10 of the Developer Kickstart. So sign up for that in April. I'm only actually half joking on that. Actually, we are doing, starting next month, we are doing the 16-week long learning how to be a developer course, which does come at a cost, so like for more affordable solutions, it's tough to say. Um, you know, Traditionally, I liked for studying for exams, I've traditionally used Focus on Force. And they are quite good at learning exams and filling in gaps in knowledge, but they're not very good for starting from the ground up. So, like, if you've never coded before, ever, um, going to Focus on Force and trying to learn PD1, you might be able to learn enough to pass, but you won't learn enough to actually be a developer. Um, Last time I checked, PD1 actually has a surprisingly small amount of actual code knowledge required for it.
Mm-hmm.
It's very weirdly named. So I
Well, yeah,
guess it depends on as well as if you're looking to start, if you have a development background, if you know it on other systems and you're trying to learn the Salesforce ecosystem, or if you're trying to learn how to code from literally ground up. Um, if you have the background, yeah, Focus on Force, Trailhead modules, stuff like that, that could probably work. From the ground up, um, it does take time. Yeah, shameless plug for CCA. But a multi-week course isn't bad. It's pretty good. If you've never programmed before, um, if you don't want to use the course, even learning in a different language would be perfectly fine. So if you find good tutorials on like doing it in Python or JavaScript or some other language or Java or some other language, that's not bad either. And a lot of those other languages don't have some of the weird quirkiness that we have on the Salesforce ecosystem because Salesforce does things a little differently than some of those other platforms. Um, and so that's kind of my all over recommendations, depending on where you are in your career and where you're looking to go and how you learn, right? Because everyone learns differently. I learn really well in a structured learning environment where I have multiple weeks and I have to have deadlines and we're learning this, then this, then this. I learn really well in that very academic lecture style, semester style thing that CCA does. But I know not everyone, that's not on everyone's learning. Some people learn differently,
yeah. Great, thank you.
and I want to acknowledge that.
A big shout out for other Mike plugging more random stuff that I'm doing. Lightning challenges is also a good option. It's similar to like a Camp Apex, Elite Code, just a site where you can go practice coding. Um, they're more focused on specific challenges, and I'm starting to work on challenges that are actually specific to like PD1 or the integration exam. But yeah, that one is just a fun little side project that I am doing. And yeah, we'll see. We'll see if I think I'll keep it up because it's kind of fun. Um, well, awesome. I think we'll kind of wrap it there. Any final words, Mike? Any thoughts, comments, before we kind of wrap things up?
Just that, program is a lifelong thing, and I'm still learning everything, and you're going to keep it's all going to change, and you're going to have to learn it all over again as you go. But everything you learn in the past carries forward with you.
Dude, I love that. Well, yeah, thanks so much for joining us, going over this really great content. I've definitely, I have you all really smart people on to learn new things. And every time I'm learning new stuff. So really cool that you've just put this together and spent the time to go over it. So we appreciate your time, and thanks everybody for jumping on. I know this wasn't a traditional office hours. If anybody has questions, stuck on homework assignments or anything like that, just leave a message in Slack and we will get it figured out. So I think that's it from there. Appreciate it, everybody. Have a good weekend.
Right. Thank you, Mike.
Have a good weekend.
Cool, cool.
Bye.
Thanks, everyone. Bye bye.